Hello, good morning and good afternoon, everyone. This is Jean-Daniel Rossel, the president of the Java Card Forum, and it's my pleasure to welcome you to this fourth webinar from the Java Card Forum 2022 webinar series. Today's topic is a presentation from Daniel Hübner of Infineon on Java Card Secure Element for the Matter-enabled Smart Home. Daniel is a system architect for IoT security, in particular for the Infineon Optiga Trust portfolio. Daniel has 15 years experience in the smart card industry, where he has developed extensive knowledge of the underlying ecosystem. Before his current role, he acted in various product definition roles for the embedded SIM and the NFC embedded secure element, as well as for smart card solution in payment and government segments. As a major semiconductor player, he was named European Field Application Engineer Champion for the NFC reader and connected tag lineup, helping customers with design and prototyping of NFC antennas. Daniel holds a degree in electrical engineering with a special focus on microelectronics. This is the 25th year's anniversary of the Java Card Forum, and Java Card is used in several legacy segments such as telecommunication, payment, government ID. But IoT is a new emerging segment which is very important in terms of security, as different regions have standards and regulation that are coming for the securing the devices, and especially in the smart home devices. So let's see what Secure Element and Java Card in particular can bring to this in the following presentation. You will notice that the microphones are muted. You will be able to ask the question when we unmute the microphone at the end of the presentation. But in the meantime, there's a chat which is open, and you can always put your questions into the chat if you prefer. And note also that the presentation will be sent afterwards, and the webinar is recorded, so you can really enjoy the webinar without the burden of taking notes or screenshots. And with this, Daniel, the screen is yours.
Thank you very much, Jean-Daniel. So yes, so I'll directly jump into the topic. Yeah, so exactly. So I want to talk a bit. This talk is obviously about IoT security here. Definitely, we saw in the last 10 years that IoT devices was really rising rapidly, and as some of the promise came true, right, of those many billion devices in the field using in the IoT, right? But to be frank, it could be better, right? So, for example, just last week, one of the big GAFA companies out there in the Valley, right, announcing basically massive layoffs, also for in the IoT branch. The problems there are wide, yeah, but some of those problems are definitely also are around security here, and this is a bit about those typical security concerns our customers have, right, which basically causes also friction in the adoption of IoT out there. As you see, 70% of the customers would purchase more IoT devices if security was addressed. So there's a lack of knowledge about security. So we see also in the OEMs problems, they could not fill all the open positions in terms of security. There is also recent surveys showing that there is also sometimes not the right level of security built in, yeah, and so there are definitely some issues around there, and I do believe that with Java Card technology we can address definitely a good portion. Clearly not all, but we can address a good portion of those security problems came up in the last years. And one way of doing this is, for example, with Java called secure elements. So also, Jean-Daniel mentioned, so the Java Card Forum now this year celebrates the 25th anniversary. Also here, congratulations from my side. I was part of that journey the last 12 years. So I was dealing with payment cards, with Java Card payment cards, then government, then later on NFC secure elements for the mobile, right? And that's always what impressed me with Java Card. They always find their way into this new market segments, yeah. And now as a system architect, I'm responsible for IoT security. And here I'm driving basically also the adoption of Java Card on discrete secure elements for IoT security. Yeah, so as you see here in this picture, so what we mean by discrete, so you see here that basically the secure elements are somewhat a companion to an host MCU. That could be an MCU or even a bigger system on chip, an MPU running Linux, right? So everything is possible. So that's also one advantage of having a secure element, because it really works with all those various platforms, yeah. And so, meaning discrete means it's a companion and not part. It's not integrated into the host MCU, right? This bears a lot of advantages. Yeah, and we see a lot of customers these days, of our customers adopting exactly this concept. So we have customers here, and especially industrial automation, for example, using this kind of discrete secure elements in the PLC drives, etc. Also now with Matter, which is a topic for me later, also we see adoption of secure elements out there in the field. So I think this concept of discrete security have a bright future, and being discrete bears a lot of advantages, and this is something I want to talk here at the beginning of the speech. So why does it make sense to have discrete security? So one of the key elements, and that's a reason why many customers buying our discrete secure elements here from Infineon, that we are able to provision this trust required in those IoT. We can provision this during the silicon manufacturing, so the earliest time possible. As you know, basically today, right? So when you have a device and it wants to authenticate to a cloud service, all those devices require a unique device identity, typically in a form of an X509 certificate and a key. And this kind of credentials, we can provision it during our silicon manufacturing, right? So basically, even when the steel is hot, right? So we can inject those secrets, those keys, those certificates, etc. already right there, right? That's a big advantage compared to, for example, if you would do this on package level or something, right? Because it's so we can do this massively parallel. Yeah, so we can that's happening during the wafer test. So we can. This is basically the big benefit here. The three benefits for customers are that we are it's massively fast. It's very fast. It's also very cost efficient, and of course the security also is relevant, as it's basically injected already in a very early time of the lifetime of the chip. Then it's also that's something we were developing those provisioning technology over the last 20 years. So we have some big knowledge of doing this, right? And we are in the meantime able not to inject simple keys or certificates, right? So we can take really very, very flexible custom configurations from customers. So with many certificates, many keys, arbitrary data, all sorts of keys, basically, customer can deliver to us, and we inject them doing the same in manufacturing. So that's one big step. The other one is also that we, with this semiconductor, with this manufacturing, we also provide here a service around the PKIs, right? So as you know, when you're dealing with certificates, you require root CA, those keys in the root CA needs to be stored very securely. So those keys are typically stored in special servers. They call the high security modules, which are very expensive. If you do this on volume, you require the personnel to maintain this, and it could easily add up to a $500K invest for an OEM. And this is basically also provided with our service here. And this is also, I found some customers told us even that a service alone is basically worth the cost of our chip. Then another one, I mentioned this already earlier in the other slide, so the modularity, right? It's also a big benefit that discrete security works with anything. So with a small microcontroller, Cortex M0, to big Linux, multiprocessor engines, system on chips, right? So we see this, we see the usage of discrete security already in mobile phones, etc., everywhere. And we have customers already who really loves this because on M0 you don't have maybe a trust zone, etc., available, right? So and they want to have the same level, the same security architecture running on an M0 work also on the big processors, right? And this is enabled by discrete security because it almost works everywhere on all those platforms the same. Another one is crypto offloading, right? Definitely, I was talking about M0s and other even more modern MCU architectures out there. As you see in those new IoT technology, cryptography becomes more and more advanced. So using the use of elliptic curve is standard right these days, and some of those MCUs are not capable of performing those advanced cryptography in time. Right here, also discrete securement is helping to boost those crypto operations pretty significantly. Secondly, also as those chips we are dealing here with coming from the payment and government world, so we have also BSI and NIST approved random number generators. So this is really, so we have customers, they simply use this chips only because of the good quality of the high entropy of the output of our random number generators, because a good random is key to, or basically is very important if you create those keys, right? So if you need a key or something which is good on a good entropy, it's great, and customers make use of that. Another one is something I call key isolation, right? It's also obviously a feature here. Basically, all those keys, right? They are not part of any OS stack anymore, right? So they're securely lying on the discrete chip, completely isolated. So not just logically isolated, but also physically isolated from the OS stack. And of course, those keys never leaving the system. And this also combined with this simpler interfaces, combined with the small operating systems developed for those chips, right? So we have here an extremely reduced attack surface, makes it really difficult for an attacker to get hold of those keys, and also it's even possible to formally certify those chips. So then here, so a little bit on a high level. So, and then I want to go a bit more deeper. What it really means is, so what we believe is that the root of trust is not just starting with the secure element. It starts already during the manufacturing, right? During the manufacturing of the chip and the provisioning, right? And that's a service we can offer. So we have those CAM-CATER certified manufacturing sites. We run this HSMs, so the high security modules for you. We run the complete PKI for our customers, right? And we can take this custom configuration and we inject it already during the manufacturing of the chip. And this is really where the root of trust is starting. This is where the trust is starting, not just when you buy this chip and mount it on your device. So it's really starting at the manufacturing. Then we're delivering those secure elements to the customer. They build it on the PCB, hook it in with the MCU, and then this provisioned trust are then used for all the different trust use cases for cloud authentication, secure communication, firmware update, and even now other provisioning services. So this is really what we mean by secure provisioning. That's something where we're also very proud of. Yeah, then and this is now a real-world example of how key isolation works. Yeah, so and the real-world examples here is secure cloud communication. So more and more devices now are used basically connected to a cloud. And there's a cryptographic step which is called basically they use for the communication between the device and the cloud service. They use the so-called transport layer security, TLS 1.3 in its latest incarnation. And there is always a step defined which is called the TLS handshake. And in this step, there is basically an authentication required. So the cloud service provider wants to make sure that the IoT device is really eligible to join the services provided with the cloud service. And they're using here the handshake defined in the transport layer security. This is typically done via elliptic curve digital signature algorithm. So advanced cryptography here, which is part of our Java card operating system, right? And what's happening here is the cloud service provider first asking to receive the device certificate, from where a public key is extracted, right? Then a so-called challenge is generated. The challenge is sent over to the device, where the device it's signing this challenge with the stored private key. Yeah, and sends it over, and this is then verified with the public key obtained from the device certificate. Right, so normally in the former times, basically those keys are somewhere writing here on a stack on the host device, right, where it's very easy accessible for attackers and so on. And this was really very often a cause for attacks and to IoT devices and so on. And we believe a much better way would be to store those very important keys into the secure element, right? And the protection of these keys is really of utmost importance for the overall security, because it's basically defining the identity of the device. When somebody gets hold of it, so you can think a whole bunch of attacks could happen right here on the cloud. And so it's much better way of doing is storing those private keys directly on a discrete secure element, where it never leaves, so it always stays there. And basically accessing those keys is also never happening directly. So there is an abstraction layer which is defined by IoT Safe. So this is a standard. So this is nothing developed by Infineon. So this is an open standard already. And this standard defines so-called interface APIs. Yeah, for example, here for this operation, a sign operation is required. So the IoT device host simply getting here this challenge and then is asking the secure element to sign it with the private key here. So it's calling here this command for signing, right? So as you see, it's never happening directly. It's only happening directly. So keeping this private key very safe here in it. Yeah, and this is really a nice feature from the IoT Safe applet, which we believe is also the future of discrete security. So this is now a little bit about the concept of key isolation. A word about the IoT Safe specification. So I was talking about the IoT Safe specification 2 years ago already here, also in the same Chromium here, Java Card forum, where I made the statement basically. As you know, IoT Safe was developed by the GSMA with the intention to bring some root of trust functionality to the eSIM, and I was making the statement back then that this is also a very good technology, not only for cellular, but also for non-cellular, like we're dealing here with, right? And so now the standard reached 1.0. What is it? So it's a standardized approach for TLS root of trust, right, as depicted, but also moreover a standard for all kinds of crypto toolbox functionality. Yeah? So when a host requires an AS function, that applet can also be used. Yeah. So also for the time being, already a lot of those TLS stacks on the host, right? Embed TLS, OpenSSL, Wolf SSL, they provide basically plugins for IoT Safe. Yeah, so eases also for the OEM the integration with this kind of technology. Then there's also now currently developing a compliance program, yeah, making sure that we as a provider of this applet really that this is fully interoperable with a standard, makes it for an OEM very easier to not be locked in with a certain vendor. So basically it's possible then to, especially in these times of allocation, right? So an OEM can switch from one secure element vendor to another, because a lot of it also logistic and commercial advances for OEMs out there. And then, of course, also this interface is designed for crypto agility, as mentioned before here. Yeah, so ECDSA, of course, is elliptic curve. We all know, basically, maybe in 15, 20 years from now, there might be the situation that post-quantum computers are around. And then it's possible to make a crypto agile switch from ECDSA to an crypto scheme here. For example, Dilithium, right, is currently released, and then we make a switch here via lifecycle management to Dilithium, and then basically, but the interfaces all remains the same. So this means really crypto agility. So there's only a little adoption needed on the device host to make then use of this new post-quantum safe cryptography, and that's also a quite advantage if you have this kind of abstraction provided by an IoT Safe applet. Yeah, so that's about key isolation. Then I also was talking about so-called crypto offloading. What it really means is, so we had quite interestingly, there's a scientific paper released. I made the link here, so that's not coming from Infineon. And so what they did is they compared a little bit the crypto performance from discrete security against an crypto performance on an ARM MCU. Yeah, in this case was an ARM Cortex M4 with 64 megahertz, and the crypto operation was a TDLS handshake, very similar to what I have shown you before, right? And this, of course, requires a certain time and also the certain time, of course, it's requiring also a certain energy because it's quite compute intensive, and this is set to 100%. So basically, this time it takes from the MCU was set to 100%, exactly the energy, right? And then we see quite endlessly that they compared here, 5-6 different discrete secure elements. Yeah, what they would perform the same cryptographic operation, and we see here that most of them perform much faster than the operation done on the Cortex, right? With the best one, we see here that they are 5 times faster than the implementation on an ARM MCU and take 60% less energy. Yeah, that's quite impressive. So why does it matter? So for example, better user experience. Yeah, so we see this later on. Matter, for example, requires an onboarding. This is really what the customer observes. Yeah, and he wants to do this, we have done really quick. And so if the crypto operations perform fast, it absolutely leads to a better user experience. Also, we will see basically also in the IoT, they're coming up some performance requirements, and those could be met much easier when you perform these crypto operations much faster. Then the energy, also, of course, a lot of those devices are now battery driven, and here definitively power matches. And so if you perform this much faster, right, and also the crypto operations occur very often, right? So in TLS, so there are some requirements that you have to create those session secrets, for example, every minute or so, right? So this crypto operations invoke very often. So definitely the power required to execute this operations definitely matters. And here also we can help. And of course, also in the PCB design, if you have to implement less heat dissipation measures, it's helping also basically the PCB the designers for their design. So that's what meant with crypto offloading, right? There's also reasons why customers are using this one. Yeah, now I want to talk a bit some classical use cases, right? I was mentioning this TLS, so this is really the TLS handshake authentication with cloud services is very important. But we see this also that customers using this here also what we call secured connectivity, right? So we have basically a local network, be it for example in an industrial automation network, where some industry automation robot, for example, authenticates to an edge computing device. So then this OEM is buying an Optiga product from us. He's building this in, and this one is then authenticating, as shown before, via TLS with a gateway, right, and making sure that this communication channel here is secured, it's authenticated, encrypted, etc. Same is true for the smart home. We have here HVACs, for example, using discrete security, and they're talking to a smart home gateway, right? It's the same principle as for PLC and also for building automation, so that some sensors authenticating to a gateway in a secure manner using TLS, using the pre-provisioned trust. And then the other way is then basically that this gateway or the edge computing device itself, it's then connected to a cloud service, AWS, Azure, Google, and many others now, right? And they all of them require an TLS connection. So they're all based on TLS communication, and they all have a way that basically this onboarding of those devices can happen via pre-provisioned trust from secure elements. This is also what we call secure cloud authentication. This is around also for 10 years now, where many customers are using this for. And then a third one is really the secure software update, right? So of course, the firmware of those devices needs to be updated once in a while, also for security reasons. And typically those firmwares coming in signed, coming with a signature, and this signature is then verified with a trust anchor certificate stored on secure elements. So that's so for what I saw for the time being, I think the most prominent use cases why discrete security was used so far. Now there's coming up a very interesting new technology for Smarthome. It's called Matter. Maybe some of you have heard about this already. What Matter is about? It's an open standard. Yeah, basically invoked by Apple, Google, CSA, so the Zigbee, now called CSA, to come basically to create an interoperability standard across all those vendors, because this was really, for the time being, a common problem which consumers seeing a lot of friction, because the U light bulb is that onboarding with Apple HomeKit is very complicated, right? Especially also across with Apple, Amazon, Google, across those different platforms, onboarding is very complicated. They have basically all this closed gardens, yeah, so that the barriers are quite high. That a device from one OEM works with the other, right? And this was basically also causing a lot of friction with consumers. Another one is also the wireless technology, right? It's also very fragmented. Yeah, a lot of devices using Wi-Fi, others using BLE, others were using 802.15.4, which is also called a Zigbee. Other one even using those 833 megahertz technology. So it's also on that wireless communication technology, right? There's also a lot of fragmentation, and all this shall be solved by Matter, right? So they come up with this open standard. So it's open. Everybody can get it. Basically, it's 800 pages long, and they define everything from the commissioning. The whole technology is now IP based, very important. So they define also the communication protocol technology. Currently Wi-Fi, BLE, and Thread is defined, because all of this can run IP-based stacks. The onboarding I just mentioned, they came up with an SDK. So basically, a device manufacturer can get also a stack implementation for Matter, which is available on GitHub. So it's also open source. So it's an open approach to come up with a common SDK for Matter devices, providing and also of course a common application layer, so that APIs are provided, so then that customers can develop their own applications. And furthermore, also an compliance test is involved, right? So that's very important, of course, to create interoperability between all those manufacturers. Interoperability is needed, and a compliance program is in place. So whenever you would like to have a device which is labeled as Matter ready, you have to undergo a Matter compliance test. And this is also a big program. So then also the onboarding process. This is checked that the compliance test for Matter has been passed. So, and this now leads to basically an improved customer experience. So what we call the Matter experience. Yeah. So customers bring home their device. It's scanning the so-called QR code printed on a device, and this invokes basically the commissioning process. Then there is so in the QR code there's a password saved, which really invokes then the commissioning process later on. Some user presence is required, so you have to push a button that the device really knows that you are around, and it's not a remote commissioning, which is not allowed according to Matter. And then basically this commissioning is triggered. And what commissioning means is that because in that smart home network, right? So the network needs to know that you're an eligible device, which is allowed to join that smart home network, and this is basically invoked here in this process. Currently, it's defined with mobile phones and BLE, so this connection uses BLE, and then there are some credentials exchanged, and a new certificate is issued, and the certificate is then later used to authenticate in the smart home network. Once this commissioning is done, basically the user is then ready to use this device. And it's quite interesting, as this shall now work basically across agnostic from any vendor, right? So basically, if this coffee machine is now from Saeco, or is it now from somebody else, it doesn't matter. Basically, the process is always the same. The protocols, the commands used here are always the same. So it creates a lot, great customer experience through interoperability. And this is now where security comes into the game. Yeah, this is here for this commissioning step. Yeah, and this is something I want to talk a bit more. Yeah, how this works is, so this is the matter onboarding flow, and OEM have to provision a secret into an IoT device, and that's already where we can help, right? So the secrets, there's a lot of keys, a lot of certificates, and that's something where we as semiconductor manufacturer can help to store those keys already on behalf of the OEM, right? And then we ship those devices to the EMS who manufacture those devices then. Then there is also, as shown in the picture before, there is they use here a kind of a secure channel protocol between the commissioner and the IoT device. It's a password authenticated key agreement scheme, right? That works in a way that the commissioner have to read a so-called SPAKE password. This is 27-bit long password. This is stored either on a QR code or an NFC tag, right? And of course, also at Java Card Secure Element is always very often able to have also provide this NFC interface here, right? So we can also the standard defines an NFC forum tag. And we can also provide this NFC functionality to the OEM, so the mobile phone then can simply by an NFC tab can read out this 27-bit password. The password is then used to initiate the secure channel between the commissioner and the IoT device. Yeah, then we have the secure channel established. What is then happening is they're reading basically one of those device identities. It was called the device attestation certificate. This is also defined by Matter. It's reading this out. The commissioning device is attesting that this is really an original Matter compliant, genuine Matter device in this step. Right, and if this is successful, the commissioner is provisioning the so-called node operational certificate. That's a different certificate and a different secret key installed on the device, and this additional secret is then used in the operational phase of the device. Yeah, and Matter defines here the Sigma protocol, very similar to TLS, which is then using this node operation secret to perform an ESDSA operation to perform a mutual authentication between the smart home network and the IoT device using this newly provisioned operational certificate. And once this authentication is successful, the IoT device can join the network. So that's a bit in interior how that works. And here's how we help with the secure element. So we help as a customer bring this provision data to the IoT device. We have this NFC tag functionality in. We also help here with performing this cryptography. This is quite advanced elliptic curve-based cryptography here, also with the SPAKE2+ protocol, right? So key crypto offloading, right? So we're helping here improving the customer experience. Be helping also here to create those keys required for the operational certificate, and then also in the operational phase, of course, we help also here. This is also ECDSA based. We help here also with the cryptographic operations, offload the host MCU from those tasks and perform those authentication steps much faster. Yeah, then. Maybe interestingly, as I was talking in the picture before, it was those trust credentials. I was showing one certificate. In reality, it's much more which have to be provisioned, and there's a little bit the list what have to be provisioned here already from an OEM to the device, and that's quite significant. So this device attestation certificate is required to be provisioned. The product attestation intermediate certificate. So this is basically the intermediate CA certificate under which the DAC was signed, a so-called certification declaration, which is also a certificate which is issued by Matter and assuring that this device is certified. right? Then also the matter specification optionally defines also firmware update, and here also the verification trust anchor certificate needs to be provisioned in that step. And then of course a couple of keys needs to be provisioned. So the device attestation certificates requires a private key. Also, the firmware update encryption key for the firmware update needs to be provisioned. And there's also some other relevant metadata which also needs to be provisioned. The setup code, for example, this passcode, right? Required for initiating the SPAKE secure channel protocol, that can be provisioned. Other values required in the onboarding process for that SPAKE, and then also any other customer data. We see also we providing with some of secure elements up to 10 kilobytes of arbitrary data storage. Then basically we can also provision this kinds of data during our manufacturing. And so this is then also the value we bring in, right? So I mean, this, as you see here, it's quite a lot of data and a lot of PKI is required for doing this. And this is something we offer here as a service to our customers when they buy a Java Card Secure Element. Yeah, so having said this is basically my last slide for the matter onboarding. I would like to conclude. As we see here, there's a lot of need and usage for discrete Java Card Secure Elements. It provides many advantages, acting here as a discrete technology when it comes to provisioning, the flexible integration. Yeah, it works with any kind of MCU, M0 to big SoCs. Also, security will be improved, yeah, because especially this provisioning topic, it's not simple, right? So what I also forgot to mention is, as we provision those secrets and in very early stage of the lifetime of the chip, right? Also those secrets don't need to travel. Yeah. So normally, if an OEM uses an ODM for manufacturing, they also need to basically ship those key certificates to them by some means, right? And this bears always the risk of overproduction, this kind of things. And this could not happen if those secrets are basically provisioned on our side. Then also we see some emerging use cases requiring new cryptography, also requiring new support levels from the Java card. Yeah, new APIs needs to be defined. I think with the Java card with the 3.1 release, absolutely going the right direction here, supporting IoT use cases very well. But also, of course, some new APIs need to be defined, and here the Java card forum is very agile. Here I see them very agile to try to bring this forward. That we also get this cryptography supported by Java card required for Matter. Yeah, and with having said this, basically I'm done with my presentation, and thank you for your attention, and I open for questions. Thank you.
Many thanks, Daniel. Very interesting presentation. So we can open the microphone if some of you have any question. Maybe I will fire this with a question myself. I think this is a great thing that Matter is a new possibility for the Java Card Secure Element, and you mentioned also the IoT safe in general. Do you see this industry is adopting the secure element, I would say, on a voluntary basis and doing ad hoc integration? Or do you think that some, I don't know, regulations or IoT security will make this as almost compulsory? And also linked to this, do you see any need or standards going out so that these secure elements have to be in this product?
Yeah, so I'm really a strong believer in that we convince the customers by features, by advantages we can provide, rather than forcing them via security schemes. That's what I believe, right? So I think as we saw, right, so there is already some friction there, so less adoption and so on. I'm not sure if we will enable this via regulation and so on. I do believe there's a lot of value in this discrete security, and I was mentioning them, and there are even more to come, right? That customers choose this kind of products on a voluntary basis, right? And I would say with the service we can provide on top of this, right? Especially with provisioning, it's we don't need to force. I think that became by itself almost unavoidable, right? So there's so much, but we only need to communicate these advantages, right? And that's what I believe. I believe really we should promote more the good advantages that discrete security have, and that's what I try with this kind of presentations here, rather than forcing customers to use security via regulations, etc. That's what I believe.
Okay, thank you. So that's for the regulation part. Now you see, for example, in the matter, this is coming from some fragmentation of the IoT market where everybody was doing his own stuff, and they see that there's some interoperability is needed.
Yep.
Do you see this also coming in terms of security, or is it different integration for different, I would say, device maker?
Absolutely. So also I was mentioning already the Matter SDK. So it's basically this open source Matter stack, which is already developed, right? So you can look for Matter SDK on GitHub, right? This is this one, and this defines already right now. So the so-called HSM APIs. So the Matter SDK already today endorses the usage of discrete secure elements out there. Right, and so for the compliance, I must say, currently Matter is more checking the compliance on the interfaces, right? It's not checking so much how this is done internally, right? So for the compliance, it doesn't matter so much if now basically those cryptographic operations required are performed on a discrete secure element or on the stack. There's nothing they check, but at least they're not prohibited, and even the other way around, they endorse it by defining already the right APIs for doing so, right? And this is definitely something which is also very often discussed, the usage of discrete security. And there is currently also a security working group around. Also tries here basically also identifies threat models, attack vectors, and so on, right? And also this kind of discussions also will help to endorse the discrete security, right? But it's currently not mandatory, right? It's definitely currently not mandatory to use discrete secure element for Matter. But here also again, I do believe we can convince via features and nice advantages that discrete secure element can provide.
Okay, thank you. We have a question on the chat, which is which mechanism is used to update the private key on secure element? Can it be assumed that IoT safe applet is always installed in secure environment, which means can't be malicious by design?
So yeah, of course, it's the coding of the applet have to have secure, right? And we from Infineon, we would definitely install this in a secure environment. And also, if the customer requests, we also would provision this in this thing in a secure environment on our sites as depicted. And yes, there is also some update mechanism, I think, required, right? So here the buzzwords are key revocation, etc. They're coming out some requirements from Red, for example, that you update those keys regularly. And also here we provide, as Infineon in the future, some lifecycle methodology to update those keys in the field also in a secure manner. And it also and it roots back also, if you do this in the field, right, it roots back to an so-called bootstrap credential. You somehow needs to connect securely to this remote system which stores those or which updates this key security. And of course this updates keys are also provisioned in a secure environment, which is then the root of trust for this lifecycle services.
Okay, thank you. Do we have any other question from the audience? I think the microphone I open if you want to ask directly the question also. Okay, so I guess everything was pretty clear and very interesting. So you will receive very shortly the presentation and a link to the recording so that you can spread the word and eventually redirect the link to some colleagues that could not attend. There is a session also this afternoon at 5 p.m. Central European time. I also encourage you to look to the 3 previous webinars of the season, which were interesting topic, and also to stay tuned because we have still 2 webinars before the end of the year on very interesting topics. And with this, Daniel, thanks a lot, and thank you to that attendance for attending. I hope it was interesting for you, and stay tuned. Goodbye, everyone.
Thank you. Bye-bye.